If you just look around you right now, your phone, the screen you're watching this on, even the lights in your room, they all depend on a piece of technology that's completely invisible. It's this hidden architect building our entire modern world, literally one atom at a time. So today, we're going to pull back the curtain on this hidden world. So let's start with a puzzle. What in the world could a smartphone, a high-performance jet engine, and a solar panel possibly have in common? I mean, on the surface, they seem totally unrelated, right? But deep down, at a microscopic level, they're all built on the exact same fundamental principle. Well, the secret, it's a coating. But not just any coating. We're talking about an unbelievably thin film, sometimes just a few atoms thick, that's been engineered to give the material underneath it almost superhuman powers. It's the secret ingredient that makes them all work. And the name of this magic, it's called chemical vapor deposition, or CVD for short. The best way to think about it is like painting with gas. You take a part, you put it in a vacuum chamber, and you introduce these special gases. They react on the surface and build up this brand new, perfect solid layer, atom by atom. This is the tech that unlocks totally new capabilities for pretty much everything it touches. So here's the game plan. We've got the basics down. Now we're going to see how CDD is powering our digital world, how it's protecting our biggest machines, fueling our green energy future, and finally, how it's totally changing the game in human health. Let's get into it. First up, let's talk about the gadgets in our pockets and on our desks. CVD isn't just part of modern electronics. It's pretty much the engine that allows Moore's Law to keep going, letting us build computer chips that are smaller, faster, and way more powerful, year after year. Okay, so you can think of a single microchip like this incredibly precise, multi-layered sandwich. CVD is the master chef here. It lays down all the different layers, the metal electrodes that carry the current, the insulating dielectrics that stop everything from short-circuiting, and of course, the all-important semiconducting channels that act as the billions of tiny on-off switches. It's just amazing. Now, this slide is a perfect real-world example of CVD in action. So some researchers were having a tough time with transistors that were, well, defective. Using this ultra-precise version of CVD called atomic layer deposition, they added just a tiny, tiny amount of titanium into the film. And that one little tweak at the atomic level fixed the defects and made the transistor's on-off ratio way better. That basically means its off switch was much cleaner, which is absolutely critical for performance and efficiency. All right, so we've gone from the tiny digital world. Now let's jump to the big physical one. I'm talking about things like aerospace, cars, and heavy industry, where parts have to deal with insane amounts of heat, friction, and corrosion. CVD gives these parts an invisible suit of armor. And you can really see the difference it makes, right? On the left, you've got your standard unprotected part. It's going to wear down, it's going to rust, and eventually it's going to fail. But on the right, that same part with a CVD coating, now it's incredibly hard, it laughs at corrosion, and it can last so much longer. That saves money, for sure, but more importantly, it makes everything safer. So how do they build this shield? Well, it's not just one single layer, it's actually way smarter than that. It's a whole composite system. First, they lay down a base layer of chromium that acts like glue, just to make sure the coating sticks perfectly. Then, they add a layer of chromium nitride for toughness, so it can absorb impacts without cracking. And finally, they top it off with chromium silicon nitride for just extreme hardness and wear resistance. It's brilliant. Okay, let's talk energy. Creating and storing clean energy is, without a doubt, one of the biggest challenges on the planet. And it turns out that being able to control materials, atom by atom, is right at the heart of finding the solutions we need. And its impact is just everywhere. CVD is used to put anti-reflective coatings on solar cells, squeezing out more electricity from the same amount of sunlight. It's used to create better materials for batteries, making them last longer and hold more charge. And it's even helping create brand new technologies that can literally harvest electricity from waste heat. And this is one of my favorite parts. It's where green chemistry gets really, really cool. Researchers are now figuring out how to use natural, sustainable stuff as the raw materials for these high-tech films. This study here shows they can make these amazing carbon films, perfect for solar cells, from the waste oil of oyster mushrooms. How wild is that? It's this incredible connection between nature and nanotechnology. And for this last section, we're going to get a bit more personal, because this technology isn't just for our gadgets and machines. It has huge, profound implications for our own health, helping us make medical devices that are smarter, safer, and just plain better. So here's a question for you. When you put a medical implant, say a new hip or a heart stent, into someone's body, what's the biggest hurdle? It's getting the body to actually accept this foreign object instead of treating it like an invader and attacking it. The answer is so elegant. You don't change the whole implant. You just change its surface. You use CVD to give it a brand new, smart skin, a skin that the body recognizes as friendly, or that can even perform a special job all on its own. And once you can do that, the applications are just mind-blowing. We're talking about coatings that can release drugs exactly when and where they're needed, others that trick bone into growing right onto an implant, making it part of the body. We can create surfaces that kill bacteria on contact, build more sensitive biosensors, and make sure implants don't corrode even after decades inside a person. So, when you step back and look at all this, it becomes pretty clear. CVD isn't just one thing. It's not one single technology. It's more like a foundational toolbox. It gives scientists and engineers the power to literally design and build the future from the ground up, unlocking abilities that honestly used to be pure science fiction. From the phone in your pocket to life-saving medical devices, CVD is this incredible, unseen architect. It's a quiet revolution that's happening at a scale we can't even see. And the craziest part? We're just getting started. We are just scratching the surface of what's possible, which really makes you wonder, what impossible problem are we going to solve with it next?